This episode of Function Junction is a recording from Azure Austin from Wednesday, October the 18th, 2017. Special thanks to organizer Justin Self.
I'm totally prepared. All right, Eric Fleming. He's this guy right here. Comes in at a solid 4'11". Eric Fleming is a lover of finer things in life, football, push-ups, and his brand new wife, Model A. When not doing push-ups or while watching a football match, he's a software developer with a passion for keeping code clean, simple, testable, readable, and fast. He's a frequent guest on the ASP.NET Monsters video cast and a founding member of Junction, so get your funk junk on, and the preeminent podcast about Azure Functions. And Mr. Timms, also known as Simon Timms, a terrible segue, is this guy right here. All right. Oh, by the way, Eric's in Georgia. Not that it matters. We'll forgive him for that. Simon Timms is a member of the Monster in the .NET community. He's a founding member of ASP.NET Monsters on Channel 9, Microsoft MVP, co-author of ASP.NET Core Application Development, building an application in 4 sprints, and founding member of Junction or Function Junction. And when he's not charming people with his fake British accent or adding extra vowels to words, he enjoys taking his wife and 2 sons, camping, commenting on PRs, and reading a good book. Your wife and 2 sons comment on PRs. Did I read that correct?
Yeah. Does your wife not comment on pull requests?
Not the public ones. Thankfully. All right. Well, ladies, it is up to y'all. Take it away.
All right. Well, thank you, Justin. Thank you.
Interrupt you real quick. If you haven't been to one of these before, 75% of these are broadcasted. So if you ever can't make it in person, you can always watch it online. For those who are online, just shoot a message in chat or on the questions section, and I will interrupt them just like I did now. For you guys, if you have any questions, just raise your hand and we'll get them answered. The mic's right here. That way I'll up here and we'll yell at them. Okay, you're good.
Good, for real now.
For that, though, no, I'm just kidding. No, you're good, really this time.
Cool. All right. Well, thank you, Justin. Thank you, HedgeSpring, for hosting us. So like Justin said, I'm Eric Fleming. I don't know if you said it in there, but I'm a senior software engineer at ClearMeasure, like you said, from Georgia, and a co-founder of Function Junction. Today, we're going to be talking about Azure Functions, expanding your application with fun-sized functions, and just kind of building one from the ground up. So I don't know if Simon had anything else he wanted to add about himself before we get started, but I'll let him do that.
No, I'm kind of uninteresting on this part.
All right. So disclaimer, before we get started, before we get into all this Azure Function deal, if we don't immediately know something, if you have questions and we don't know an answer to something, definitely make sure that we get the question, we lock it down, and we will do either an episode on Function Junction on YouTube and Channel 9, or we'll at least write a blog post about it and get you an answer, as fast as possible. All right. So why are we here? We're going to talk about Azure Functions. Kind of what are Azure Functions? When should we use Azure Functions? We're going to have a little demo of building a URL shortener. And this will give us a really good opportunity to show off the development tools, how you can unit test, best practices, deployments, statistic gathering with application insights, scalability of Azure Functions. And then, we'll hopefully be able to answer all the questions that you have. And this is the second to last slide. So we're not going to bore you with slides. We're going to get straight into kind of talking about what these Azure Functions are, Visual Studio, the Azure portal, all that. So
some people would call it the penultimate slide.
Yeah, yes, it's a great word. Mm-hmm. So I'll turn it over to Simon for kind of give us a lowdown of first what is kind of this whole serverless aspect, and then what are Azure Functions.
Okay, sure. So I wanted to start off by talking about what serverless is. It's a bit of a buzzword at the moment. And I know that a pedantic number of people out there are saying to themselves, what do you mean it doesn't run on a server? What does it run on, a potato? It absolutely runs on a server. And then they shake their fist angrily at clouds that are passing by. So to address those concerns, yes, it's true. It is not truly serverless. So in my mind, serverless doesn't mean that it doesn't run on a server. It means that at no point do you have to manage a server. And in fact, I'd take it even further than that, and I would say that at no point can you manage a server. You shouldn't have any concept of what is running under the covers, how many machines your stuff is running on, where it's located. All that sort of stuff should just be abstracted away for you. It should be handled by some framework somewhere that you don't need to know anything about and is written by people with 4 PhDs and a dog named Fred. So you don't have to worry about any of that stuff. The other part of serverless in my mind is that if you don't use it, you don't pay for it. So the idea here is that if you have a serverless application standing up and 1,000 people use it, you're going to pay for 1,000 people. But if 0 people use it, you're going to pay nothing for it. So that's the ideal scenario there, is that the scalability is entirely linear based on the number of people that are using this service. So that takes us to Azure Functions. So Azure Functions are a relatively new offering from Microsoft. And what it is basically is a discrete, isolated, triggered block of code which runs without context in a highly distributed fashion. That's like a $6 definition of what it is. But basically, what it boils down to is instead of writing an entire application and deploying that, you're going to write individual functions that are just endpoints that either consume a message off of a service bus or off of queues or something like that, or listen to HTTP requests, perform some action, and return or pass information on to an additional function further down the line. So Azure Functions have a number of different triggers that can be used to start them off. I mentioned a couple there. So there's Azure Service Bus, queues, putting entries into blob storage, HTTP requests, and there's a couple more in there. We have a series of videos if you're interested in drilling into what those all are. And what I mean by isolated here is that running a function should have no side effects on other functions that are running. So you don't know that there are a bunch of other functions running at the same time. There may not be. There's no kind of global state that's available to you. I say that, but that is entirely true. You could put in a global state, but please don't. And we're going to set up these functions to just run really quickly and to run relatively small pieces of code. So, Eric, why don't you tell me when we should use Azure Functions?
Yeah, so Azure Functions, well, you should use them for everything. No, I'm kidding. So Azure Functions, they have a few main draws. You've touched on a few. Kind of like the main one, I think, is this pay-as-you-go aspect. So you could have some processes that you have in your product that only need to run once a day, once an hour, once a week. Some kind of background process, something like that. Something like that is perfect for an Azure function because you're only going to pay for the execution. The process of running that specific function. And it's down to like the millisecond of processing time. It goes based on payload size as well. And if you're interested in that, seeing how much it really will cost, they have a great pricing calculator. You can put in some, variables that you think you would use, and it will spit out what it would cost you. And it's really not bad at all. So that's one main use. Another, main use for these Azure functions and main draws of it is scalability. Scalability for Azure functions is really just built in. You deploy these functions out, and it will go. They're different criteria mean that it will scale out. So, for example, like if you have a bunch of messages in a queue, depending on the queue size, it's going to determine how much it needs to scale. Response times, et cetera, depending on kind of like what the trigger is, what the function is supposed to do. And it's really just all taken care of for you under the hood, as you deploy it out. Kind of with that, it removes a lot of overhead for your deployment pipeline. So like if you have something, set up with VSTS or you use an Octopus deploy or something like that, it's really simple to just deploy these functions out and have something up and ready to go in very little time at all versus, if you have like a scheduled task that you have to run, you have to set up maybe a script, a new project to handle whatever is going on, manually log on to some server somewhere, set up the Windows task scheduler, etc. Like that can all be solved with a timer trigger in an Azure function, and you could have it out the door in a couple of minutes. It's really, getting things up and running is very easy. And so most of us, I guess maybe I shouldn't make the assumption, but most of us are probably .NET developers using Visual Studio or have used Visual Studio. And the dev tools for Azure Functions are pretty fantastic. We'll get a chance to see all these in action. But with that, with having a good, set of dev tools, like you can set up these projects in Visual Studio alongside your normal solution. And it's just an Azure Functions project that you can set to just run with, your console app, your web app, what have you. It can be set up, in your solution. And with this also means that you can follow the best practices that you would follow, normally with everything. Like even though these are functions that run, serverless, kind of different than a web app, they can still be developed side by side, run. You can write unit tests, you can have the same folder structure. All these Azure functions just get rolled up into a DLL anyway. So yeah, it's just going to pull in whatever references that you need. Local debugging is great too. Deployments become easy. Getting up and running with Azure functions in your solution now is very simple. Another thing, attribute bindings have made, in my opinion, has simplified connecting to different sort of storages, queue storage, blob storage, and such. Like it simplifies it down to, it removes a lot of the cruft. Basically, you add an attribute binding, you add an entry into your settings, and for the connection string to whatever you're trying to connect to for the trigger, and it just does it. It sets it up. It's ready to go. You don't have to write a bunch of code to connect it. It's done. Ready to go. Statistic gathering is very simple. Like literally all that you need is to use application insights, and all you have to do is set up a token from your application insights from your Azure portal. All you have to do is set up that token in your functions app, and it will automatically just wire it up, and it'll start collecting metrics, and we'll see that too here shortly. So I think that covers it for why and kind of when and why we want to use Azure Functions. So, but Simon, are there a couple places where we may not want to use Azure Functions?
Yeah, I think there's a couple of places that you might want to consider not using Azure Functions. So the first of those places is if you have something that is a really long-running process. Maybe it takes 30 minutes to run, and it's a process which is not easy to parallelize. So if you had something that was like maybe encoding a video or enumerating the number of jelly beans that I've eaten in the last day, like something that was really gnarly and had a lot of complexity like that, you wouldn't want to run that inside of a function. And the reason for that is that the consumption plan for functions has a limit on how long a function can run for. Now, if you have something that has a really long runtime, but you can break up into a lot of steps, then functions might be a good solution for you. And you could look at durable functions, or you could look at spanning the function out. So if you have something that you could split up into 100 or 1,000 or 10,000 parallel tasks and run them simultaneously, then that's a great application of functions. Another place that isn't great for functions is if you have a process that has a high startup cost to it. So if you have something like nService Bus, where in order to start up an instance of nService Bus, you're looking at kind of 20 or 30 seconds to spin up everything, you might want to avoid using Azure Functions for that. And one of the reasons around that is that, of course, you don't want to pay that high startup cost every time you process a message. But on top of that, you don't want to waste a lot of time in Azure Functions, because the billing model for Azure Functions is based on megabyte seconds, which I know sounds like a made-up metric. And the reason for that is because it's a made-up metric. But basically, it's a unit of measurement based on how long your function is running for and how much memory it uses. So you ideally want to optimize for short tasks that use very little memory, if at all possible. So if you're going to be parsing XML, use a sax parser. So those are the kind of times that I wouldn't necessarily recommend functions, but as Eric said, pretty much any other time, functions are the way to go. So let's jump into a demo and walk you guys through creating a function. So let me share my screen here.
I guess, are there any questions before we kind of jump into the demo?
Nope.
Cool.
I know you guys are out there. I can hear you leaving. All right. So what I've got here is a Visual Studio instance with a function project loaded in. And this is pretty easy to create. If you want to create a new one, just do File, New Project. And if you have the function tooling
You're
installed.
waiting on the screen to show up.
You're what, sorry? Oh, we're still waiting on my screen to show up. Oh,
Unless you're showing just a black screen that says Simon Timms has started sharing.
If he's doing dual monitor.
And there's Simon. Oh, here he comes.
All right, let's try that again, maybe. Have I started to share now?
There it goes.
All right.
Probably because Trump has the NAFTA agreement with Canada. It's all, you know.
Yeah. You know, the first 30 minutes of a meeting are tariff-free, but after that, it's a 220% tariff on it, just like Bombardier claims. Anyway, that's probably more of a news story up here than down there. So this is how you would create a new project. There's just a template here called Azure Functions. So this is installed. I don't think it's by default in Visual Studio, but there is some tooling that you can add in just through the tools extensions to get Azure Functions set up for your project. And once you've got it loaded, you'll notice that it's basically just a class library. And there's some nice tooling built in here that if I wanted to add a new function, I can just go down to Add, New Item, and then there is a function template in here. And there's even some great tooling to give you some skeleton functions here. So we talked about how there's a bunch of different triggers that you can use. So these will be some of the triggers. These will be templates for what they would look like. So getting for HTTP, blob triggers, timer triggers, all of that stuff. So this will give you at least a good starting point to build your application. So let's start off here with this. So our goal here tonight is that we want to build a URL shortener. So I'm sure everybody has used one of these at some point in the past, but ours looks a little bit like this, where you put in some URL. Oh. Sorry, Microsoft sponsored event. And then you hit shorten, and it's going to come back with a short link that you can then post to your friends to get shorter. The way we have it set up right now, it's more of a URL longener than a shortener. But that's a useful thing to have too.
Perhaps. We have a different domain we can use for that.
Yeah, we haven't quite got the domains hooked up yet for this. But anyway, so what I started off here with is an HTTP trigger. So this is what we're going to use to shorten that URL. If you were to jump back to that application, you can see that we're just posting some information to an endpoint, and it's going to reply back with a short URL for us. Excuse me. So a couple of things to note right off the bat is that we have this HTTP trigger annotation at the top here. So what we're saying here is that this function is going to be started with an HTTP trigger. So it should be listening for people to send messages to it, and it should be listening in particular for people to send post messages to it. And it's going to be listening at a URL that contains the word shortener. So once that comes in, it's going to populate this request here. And the other thing that's going to populate here is this collector down here. So this collector actually talks to table storage. You can think of this as talking to Cosmos DB. It's effectively the same interface at the moment, but functions haven't quite caught up with the Cosmos DB tooling yet, so they're still using the table storage endpoints. But I have been told that secretly the Cosmos DB table storage, their key value store, is actually table storage under the covers. So that's going to hook up a collector here. So this is a quick and easy way to get into table storage. We're going to use this connection string called table connection, and we're going to use a collection called URLs. And then the last parameter here is just a logger. So if we wanted to write out log information, we have a convenient trace writer sitting right here, ready for us to go. So I'm not going to treat you guys to too much of my typing here because it's not the quietest thing in the world, but I'm going to start stepping through this function here. I'll just copy it from somewhere that was built earlier. So right off the bat, we're just going to do some logging here because we love logging. And then Eric decided we needed a stopwatch in here because every good function is timed. We wanted to show off how quick everything was. Now we're going to go off and get the parameter from the query string that we're going to use to shorten. So this will be the URL that's being sent to our service that we want to shrink down a little bit. If that URL doesn't exist, then we'll throw an exception here, and we're going to return an error message back to the caller. So this is going to flow back out as it would through any sort of web application back to, in this case, an Angular application that's calling this API to tell them that there's some sort of batch request that's come in. So moving on from that, we are not necessarily getting the URL from the query string. We also want to be able to support getting the URL from the body. So we're going to add in this little bit of code here. We're going to request the content of the request. And this is all nicely asynchronous, so the support for async and await in here. Functions at the moment runs on top of .NET Framework, full framework 4.6.2. So it runs on top of that in deployment scenarios too. There is work currently going on to support functions on .NET Core. So as a result, all of your functions actually run on Windows machines currently, so there's no support for Linux as of yet, but that might be something that comes along kind of in the functions 2.0 timeframe, because it'll be supporting .NET Core, and of course .NET Core is portable to other platforms, but not OpenVNS, unfortunately. So once we're at this point, we now have the URL. So all of this is kind of a little bit of craft ahead of time just to get the URL for us. And then once we've got it, we're going to generate a new short code from this. So that's going to be the bit that you would see on the end of the URL, like this little kind of random looking string right here. And we're going to log that information back out to our logs because we love logging stuff. And then the real key part here is that we want to insert this information into table storage. So typically inserting into table storage would be kind of an involved process. You'd have to set up a client and find your partition key and all of that stuff and insert it in. It would be probably like 15 lines of code maybe. But because we have that collector that we set up here coming in, all we need to do is just do collector.add, and we're going to add this handy dandy URL model, which has a random ID on it. When we created it, the URL, some row key, which is actually going to be the short code. So this allows us to look things up quite quickly, because when requests come in that we want to forward, we're going to have the short code, and we're going to be able to look that up very quickly in table storage. And then I'm using the partition key URL. So I'm using a single partition. So if you are looking to scale your service out a bunch, probably don't do this, because there's only going to be one partition that's running all of this stuff. And it will get pretty hot if you're running a lot of URLs through it. But still, for the demo purposes, it's just fine. So all of that is now saved off. And all we need to do now is just kill our stopwatch, log our exit information, and we're going to return back to the client the short code that came in. And that is pretty much the entirety of our application for shortening. We have a sister file here called redirect, which is pretty similar. So again, we're going to have the stuff come in for us. So we're going to pull in the code from the request. What does this code come in? Is it actually used? It is. Okay, so the code, okay, so here we have bound a route to it here. So we're going to pull the code out of the route and insert that in here. We have a URL model, which is coming from table storage. So you remember that we're going to request information from table storage, and we're going to give it the key code. So that's how it's going to know to look up a URL model. So it does all of that hydration for us by itself. And once we have that information, then what we're going to do is we're just going to send a redirect request back out again to send to a different site.
Yeah, and that line 16 there, that table that table attribute with the URL model. That is literally all you have to do in order to retrieve that record from table storage. Everything is set up. It will return that URL model straight from table storage, and you don't have to write any more code to retrieve that. That's it.
Yep. So now we've got all of this set up. Are there any questions about this code before we move on to deployment?
I was going to make a couple of comments.
Yeah, please do.
So if you switch back over to the shortener class there. So this all, like when we hit, if we would debug this locally, we would have set up the table connection in our local .settings.json file. And when we do that, it will, we have there are some tools. I don't know if you guys have used them. It's Windows Azure Storage Explorer. That is great for kind of visualizing the tables, the blob storage, everything that you want to simulate locally. And it will display it to you pretty simply. And you can also use it for your actual Azure account to visualize it. But if we had the local.settings.json set up, all you have to do is set up the connection, use development storage equals true, and it will wire it up for you. And I think just a side note, every trigger except for HTTP triggers will require you to have the storage emulator running, because it will need something to like populate a schedule or some sort of entry to hang on to in order to know where to pull the values from. So yeah, go ahead, Sam.
Right. Yeah, so this is what a local settings file is going to look like. Yeah, I think we have our git ignore set up to not check this in at the moment, but this is what it's going to look like. So right now we're just pointing at using development storage here. So let me spin up the storage emulator here. Storage emulator. And then we should be able to kind of kick off this function here. You can see what it looks like to run this stuff locally. So there's a great little runtime that, assuming I put all the code back in shortener properly, will just kick off. Oop. Oh, that looked like it was what I wanted to be. I didn't quite catch why that failed. I don't know what I screwed up in there. Fortunately, we have such a thing as Git. I can see what I screwed up. I feel like I screwed it. Yeah. Anyway, there's a local runtime that will just run this stuff locally on your machine using whatever settings you have set up already. But we wanted to see about deploying it out to the cloud. So we have a very handy looking project here in VSTS. So this is what a build of this project looks like. It's pretty simple. We just end up doing a NuGet restore, build a solution, running the...
Can you make that a little larger?
Maybe. Ooh, like that large? Is that large enough?
It's pretty large.
Yeah, it feels like insultingly large, like Texas large. Okay. Right, so it's just kind of a standard build process, pretty simple. We're going to do some NuGet restores. We're going to build a solution. We're going to run tests against it. So that's something I think that Eric and I wanted to highlight a little bit, is that because this is just a standard Visual Studio project, it's just a class library, you can test it just as you would anything else. So we have a bunch of unit tests here. They're using XUnit. There's some slight trickery to getting it to work properly. We have a video up on a couple of settings that you need to change in order to get this to work perfectly. But for the most part, you can just write unit tests against this as you would against any other code base. So we're going to run those tests here, and we're going to go into a deploy here. So in a real project, you would probably do this as a release instead of a build, but we're just going to slap it right in here to the build. And this just goes out into Azure App Services. So all of this function stuff actually runs on top of Azure App Services. So all that stuff that you have seen with like being able to scale and resize machines and all of that stuff is just native to Azure Functions because it is built on top of Azure App Services. And in fact, there are two modes that you can use to deploy Azure Functions. There's the right way and the wrong way to deploy it. So the right way is to deploy it using this thing called a consumption plan, where you're billed by the megabyte second, and things scale up transparently for you and scale down. Everything is seamless and wonderful and fully serverless. And then there is the wrong way, which is you deploy this as part of an Azure App Service, and then you pay for the Azure App Service. So you might pay for like, hey, I want to pay for 2 machines for a month solid, and it's dedicated to you and to this functions application. So that means that you're going to be paying for 2 servers for a month, whether anybody hits it or not. And you're going to be limited in terms of scalability to whatever it is that you set your scalability to in your Azure App Services deployment. So as you may have sussed out, I'm not too keen on that deployment model because I feel like it loses all of the advantages of Azure Functions, and it kind of just drives you back to the same way that you've been doing everything up until this point.
Simon, got one comment for you.
Yes.
There actually is a really good use case for the standard hosting plan. Let's say you already have a website that's already running on Azure App Service, and you want to just add one timer trigger to do something on your website, or one function to go do some little thing. You don't actually have to have something else special. You can deploy it to your already existing plan that you've already paid for. So I do see some customers using, when they're starting Azure Functions, if they already have something already, they might add just tossing it onto what they've already paid for, what they're already paying for, instead of spinning up another consumption plan. Then again, if you're consuming very little, you might not get over the 100,000 that Azure Function calls we give you for free, or whatever the default free tier is too.
Yeah, that is one time that you want to use it. The other time that you might want to consider using it is if you have, say, PCI compliance requirements around TLS. So you can't use TLS 1.0 at the moment. There is no way inside of Azure App Services or inside of Azure Functions to disable TLS 1.0. So please feel free to write your friendly members of Microsoft and tell them how stupid that is. So in order to get that to work, you have to run it in a separate environment, an ASE. So you could run Azure Functions inside of that ASE and then turn off your TLS 1.0 inside of that. But in theory, if Microsoft want their services to continue to be PCI compliant, as of June next year, they're going to have to surface some way of turning TLS 1.0 off on Azure App Services. So it should be a temporary problem anyway, and not at all one that I have been running into, pumping my head against at work. Right, so what does this look like up in the portal here? So I'm going to jump over here and take a look at this. So this is Azure Functions running in the portal here. We have our application set up here. You can see we have a number of triggers here. These are the ones that are similar to what we have built out already. If you wanted to build something really short. Yeah,
Simon, sorry. I think it looks really good, but nobody can see it.
Nobody can see it. Better?
There we go.
All right. Right, so all of your functions are surfaced here, so it lets you see them. And we've also surfaced a couple of proxies here. So the proxies allow you to do URL rewriting effectively. And you can use your Azure Functions application to front a number of different services. And in fact, you'll see that we have this little thing in here. So what this is doing is we have blob storage. Our Angular application is just running as a static website inside of blob storage. So that way we don't have to pay for any hosting for it because it just lives inside of blob storage, or any like plan. We still pay obviously for transfer costs and all of that for blob storage, but this function is going to front it, so we don't have to send people to this rather confusing URL. We can send them to a shorter URL. So see that we're just sending people to like funkjunk.com in order to get to this. So that's what this proxy does, and then we do similar things for the redirect, just making things a little bit shorter and more concise.
We also have the domain, if you want to go to the custom domain there.
Yes, I always forget where that is over here. So yeah, we have a custom domain set up here. And at the moment, we don't have any SSL fronting this stuff, but there is, of course, the ability to go and upload your own SSL certificate for this right here. Okay.
And I will say, so with the proxies, you can set up the proxies in a proxies.json file that you can have in the root of your, yeah, there you go, right in the root of your functions app. You can set those up and it will get deployed out when we run the deploy that we just saw in VSTS. I will note that right now there is a bug, and I have an open issue on GitHub for it, to where if you deploy these out as is, they will be displayed. But you notice how in our proxy section we have site to and redirect to. They're not taking, and they're not working when they just are initially deployed from VSTS. So when to fix that, you can actually go to the proxies, and there's an advanced editor which will actually bring up the Simon, if you want to click on proxies, the read only in the left hand side. Yeah, right there. There's an advanced editor somewhere, maybe click on site 2, that you can actually edit the proxies.json that you have. It'll get overwritten with the next deploy. But you can edit them. So the bug is that they don't take initially, but if you come into this advanced editor, copy and paste them and rename them, delete the initial ones, they will take again. I imagine this will get fixed up in the next couple days or weeks here. So they're aware of it. I think there's been 2 issues reported around it. So if you're planning on using proxies in the next couple days, then just be aware of that. Yeah.
Okay, great. So you can also write functions in the portal if you wanted to. Like, you can write functions in C# or in JavaScript, maybe even in Java now, directly in the portal. But that's not really very DevOpsy. So you can't have a proper build pipeline set up to do that. So it's better to build them in Visual Studio and then run it through something like VSTS and deploy it out as you would any other app.
Hey, Simon, got a question on site.
What do you got?
I was wondering if you can provision the Azure function through something like ARM templates, or is that not a good candidate?
Did you hear that question well?
I heard the first part.
Right,
Something about provisioning. Yeah, provision with ARM templates.
Yeah.
Is that the question? Yes. Absolutely, you can. Because it's just app services, you can just provision it as you would normally with a template. And I'm sure everybody knows this trick. But you can, if you're trying to build something up, you can build it up in the portal, and then you can go and download the automation script right here, which allows you to build it up. So if you're not sure what the script is supposed to look like, if you're new to templates, or you don't feel like you can write all of this stuff by hand, you can go build it up and then copy it down and make changes manually with that. It's okay to do that. It takes a lot of work to kind of clean it up and make it sensible. But that's a good little trick. All right. So do we want to talk about maybe app insights for this?
Yeah, so I think we have a little, what we did was to kind of demonstrate scalability of these Azure functions, we spun up a queue that has a bunch of messages that's going to hit the shortener function. So there's a bunch of URLs. There's, I don't know, Simon, how many is there? A couple thousand?
8,688.
Right.
URLs.
So we have all these messages that we're going to switch basically the config setting of where the queue is going to be looking for. Which is another good point. So when we're setting up these application settings that we would normally set up in like our local.settings.json, we can set them up here. You can set them up in VSTS with some values, and you can set them up here in the Azure portal. If you guys saw that, is in the function app settings. And so Simon's just going to change this queue connection, point at the queue that has all of those messages in it. And as soon as he does that, the function is going to start processing all of those, and then we're going to switch over to application insights as we do that to kind of see the live stream of the function processing all of these messages, and then we'll hopefully be able to see that it scales out to another server once the load gets it recognizes the load is high and response times and everything like that. So
I was going to do that, but it's not actually an app setting. I don't think it's compiled into the application.
Oh, nice.
So maybe change real quick here. If I can remember. Maybe I'll just okay. URL demo is I think the one that we changed it to.
If you want, we can add the setting to master and watch the whole pipeline deploy it out.
Yeah, let's do that here. So hopefully I have the latest version of all of this code. So in shortener, I have the queue populator. So this is a queue trigger. It's just doing exactly the same thing as the URL shortener, but based on a queue trigger instead. So URL queue demo. I'm pretty sure the name of the queue that I created. URL queue demo. Then I will
Or we'll do this and it will break the whole thing.
Wait, don't you need like a pull request and a code review and then QA?
That's not how we roll.
Yeah, absolutely. We totally did that. You just blinked and missed it.
Just ship it. Okay, I got it.
Yeah.
So I see there's a question here on the forum while we wait for this thing to deploy out. Can you right-click and deploy an Azure function? No. Yes, you can. But please don't.
No, the answer is no. You can, but you should not.
Yeah, you can just run through the same publish process that you normally would. Yeah, so I can go and select an existing, and I could go and publish it out. But
yeah, that stuff's good for demos, but not really for. I mean, who's going to launch their serious production app by right-clicking inside of Visual Studio?
It feels like you've done that before.
No idea. I would have never done that.
Totally would have.
I can tell you that for comedy effect here, when I mentioned earlier that you can set up an ASE to turn off TLS 1.0 to make your stuff PCI compliant, there is a slight hiccup with that in that web deploy uses TLS 1.0. So as soon as you turn it off, you can no longer deploy your site. So that's another fun learning. So we got that out there. Let me pull up.
I think you have to trigger the build.
Oh, I gotta manually trigger the build. Oh,
You didn't turn it on.
gosh.
You can turn on the continuous integration that whenever something goes into master, it would
Okay.
would automatically go.
So we have triggered that build, which is hopefully running. It isn't too far down the build queue here. Waiting for an available agent. Story of my life. Okay, well, while that is running, let me talk a little bit about application insights. So has everybody used application insights?
We might be able to if we could see it.
Oh my goodness! You gotta zoom in. There goes.
So finicky. So yes, I'm impressed. I see just a flurry of hands jumping up. People are enthusiastic about application insights. I see one guy dancing in the back when we started to talk about this. That's really nice. I really appreciate that dance. I would have appreciated it more if you could have kept your clothing on.
UG.
Anyway, so Application Insights is a fabulous tool that Microsoft have been pushing, not hard enough in my mind. And it is a log aggregation tool, but also like a monitoring tool. So if you have used something like Sumo Logic or log entries, then Application Insights has that similar functionality where it will aggregate logs from a bunch of different places down to one easy to search location. And it also has some abilities around kind of monitoring the performance of your service. So it's sort of like a hybrid between New Relic and Sumo Logic, kind of bringing all of that functionality together in one place. And what's really nice about Azure Functions is that it has Application Insights pretty much built right into it. So in order to enable it, all you have to do is just add your Application Insights instrumentation key here, which you can find just by kind of going to Application Insights and asking for the key. somewhere in here, which I won't be able to find quickly enough. Instrumentation key. I guess I could find it quickly enough. So this is going to send all of the information from Azure Functions directly into Application Insights. And it's also going to send all of your log information. So that stuff that we wrote to that trace log inside of the function, that's all going to end up inside of Application Insights as well. So what we're going to do here once this service gets up and deployed, which I'm hoping is right about now. Okay, good. Looks like that deployed out properly. So in fact, it's probably already running. We had 8,000 messages in the queue.
You may have to change the proxies.
Well, let's see if this is running. Yeah. Okay, so you can see that the service has started up and it's starting to consume messages now. Sorry, I don't have any way of zooming this one, Justin. Oh wait, there's like a Windows magnifier or something, right? Egg. Fire. Ooh, there we go. So we had about 8,800 messages in the queue here. I'm just going to refresh this and see where we're up to now. So you can see we're churning through messages fairly quickly. We're probably doing about 100 a second based on my quick counting here of refreshing. Now this is quite interesting. I don't know if you guys caught that, but I refreshed a couple of times there and the message count remained the same at 5,440. Now I suspect what's happening behind the scenes is our server is actually scaling up. Or scaling out to handle these messages. So now, in fact, you'll notice that the number of messages that are being processed in a second is higher than 100. So we're probably doing about 200, maybe even 300 messages a second now. I'm assuming that every refresh takes exactly 1 second. That was a big jump in messages. Anyway, this information, once I figure out how to get out of Zoom here, this is the sort of thing that professional presenters such as myself have down like a science. So we're going to take a look now at where those requests ended up. So this is Application Insights. This is what do they call Application Insights Analysis or Analytics. It has some other cool name that starts with a K that I have forgotten. So I don't know what the internal code name is for it. But this allows us to write queries against our logs. So by default, we just have a bunch of requests that come in here. So let me show you what that looks like here. So you can see kind of like the URLs that were hit and kind of information around IDs and what was done with that. The field that I'm particularly interested in right now is I want to know about what server this was running on. So if we scroll over through all of these things here, one of these columns, which I've totally lost now, is the name of the server that it's running on. It's called...
Should be Cloud
Roll Instance. It might not be I might have to add that column. Yeah, we go. Cloud Roll Instance. So I talked about how serverless is not truly serverless. There are servers behind the scenes, and this is those servers here. So just at a glance, you can see that there's a couple of different services running on. Looks like 2 just in this set of logs here. This one and this one. So let's go over and take a look at this query here. So what I've done is I've asked for all of the requests that came in the last hour, and I'd like to have those summarized by role instance, and I'm going to bin them into 1 minute intervals. I'm going to change that maybe to 1 second. Let's start with 1 minute and see how that goes. And we run that. So you can see here kind of the number of requests that were processed each minute. You can see that at some point here we switched over and we added another server instance. So we'll see that a little bit better if I bring the resolution down here. And maybe I'll change this to 30 minutes. There we go. Switch back over to the charts here. Ooh, that's still maybe a little bit long. Let's just do 5 minutes, maybe. Okay. So you can see us processing messages happily here. We're processing, my guess was pretty good. We're processing sort of around about 80 messages a second here, a slight jump to 90. And right about that time that I called it out, when we hit 5,440 messages, you can see that we stopped processing just for a couple of seconds here as we start to spin up a new instance. So after that happens, it takes just a few seconds for that instance to come online. And now you can see it's starting to process a bunch of messages too. So now we're running across 2 instances. So this automatic scale up was just done for us. We didn't do anything or change anything to have this happen. And if we'd had even more messages inside of that queue, somewhere along here, we'd see another instance of scaling up as it grew to like more and more and more machines until it was running on a lot of machines. The exact number of machines that they run Azure Functions on, I don't know, but they did mention at one of the Azure Functions stand-ups that there are some regions that they run on as few as 10,000 machines. So I'm an old person, so having 10,000 machines seems amazing to me. For young people like Eric, that's just like the number of machines he uses to run Counter-Strike. That's a game, right? People play that game?
Long time ago.
Okay. Oh.
Well, no, it's still on.
All right. So that gives you an idea of kind of the scale up of Azure Functions and how nicely that all comes together without having to worry about any intervention on our part.
Right. Yeah, and like the simplicity of application insights, like we were talking, we kind of touched on New Relic and Sumo Logic or something like that. You know, some of those logging tools, like this is just there. All you have to do is add that key, and it's ready to go. You know, with the other stuff, like you have to somehow get an agent on a server somewhere, or you know, I'm sure they have their cloud options and everything now, but it requires a lot more manual work to get that up and running. With Azure Functions, it's just here's a key, and you're going to be able to start reporting and pull in some graphs and kind of watch what your function app is doing.
Mm-hmm. And the other really nice thing about application insights is that you can consume information from a number of different sources. So we had just Azure Functions hooked up to this, but you could hook up your external website to it. You could hook up blob storage to it. You could hook up any number of different things. And that way you can like aggregate all of your data together. Another really nice thing to hook up would be your deployment. So that you could draw kind of deployment lines, and you could say like at 3 o'clock there was a deployment, so that you can go back and you can see, hey, we were running at 30% CPU when we did this deployment, and now we're running at 80% CPU. I bet you that deployment has something to do with this.
Right.
So anyway, a fabulous tool. So I don't know that we had a whole lot else to talk about as part of this. I think we maybe just wanted to demo this working. I already have kind of a little bit of a demo here that went from bing.com to this much longer URL. So you can just click on that, or maybe I'll just copy the link here and open it up in a new tab.
Okay. It's
so
you may have to change the redirects after the deploy.
Oh, well, let's give it a try and see what happens. Yeah, looks like we're being hit by that proxy issue again here. So I won't go back and bother reconfiguring that, but as we said, Microsoft is aware of this problem. They will fix it, and I promise you, if this does work, we'll get a proxy redeployed out in a little bit for it. So that's pretty much it. Oh, the one other thing that we had to set up to have this work was we had to set up cores, so cross-origin resource sharing. So that's sort of like the one.
All right, hey guys, we got one question here on site, one in chat. So
okay, let's pause. And which one would you like to answer first?
I'm going to do on site.
If you could pull up the function, the source code for the run method.
Yeah, the queue or the shortener.
Either is fine. I was curious how much flexibility you get on your input parameters, and if you wanted to talk about how those actually get magically resolved.
Sure. So the input parameters, there's a variety of different things that you can hook up on them. You can certainly hook up the trigger, and then the support for a wide variety of Azure services in terms of just being able to kind of hook them up. So this is table storage. There's also ways to hook up like Cosmos DB, well, Document DB as it was when this was published. Event bus, storage queues, service bus queues, event hubs, those sorts of things, event grid. So there's a lot of ability in there.
Were you kind of after like, Simon, if you go to the redirect one, were you after like the code part, like how that just kind of gets magically, like on line 15 where we have string code and just comes in from the parameter, almost just like a normal web API request like you would have.
It was probably poorly phrased. I guess what I was trying to determine is there's probably a restricted list or a special format of how you have to have it set for it to work properly. I couldn't just say, give me object O, give me int I, and expect it to do something useful.
Yeah. Go ahead.
Yeah, you kind of can. So if you've ever used Web API or ASP.NET MVC, you might have seen these route parameters that you can add. So there's kind of a parsing engine behind the scenes that will pause the request in order to pull this stuff out. But it is kind of a little bit of magic in order to get this like this, but it will try and be fairly intelligent. So this string code could be an int. It would parse that correctly. It would probably also parse like date times and a number of other things.
Okay.
All right.
Yeah.
Got one question online. Can you limit the max load for a function request?
Yes, you can. I totally don't remember how to do it, but there is the ability to do that. So they added that because they didn't want to overload some services. So if you have something that, say, reads a queue and then makes an HTTP request, and you want to make sure that you're not overloading whatever API it is that you're talking to, you can set kind of a maximum throughput and say, I don't want this to do more than 5,000 requests a second.
You can also set a spending limit too, or your gigabit seconds limit.
Yes. That's true, but that's more of like a total number, so as opposed to a throughput per second limit. Yeah, but you could say, like, I don't want to spend more than $5 on this function.
Was there one more question?
Jeffrey would like another highly thoughtful question from Nolan. So, Nolan, get on that.
Is there, what kind of support is there for guaranteed delivery of these different triggers?
Did you catch that?
So what kind of support is there for delivery of?
Yeah, so guaranteeing the delivery of the trigger. So, I'm assuming if a message comes into a queue, guaranteeing that this is gonna get processed.
Only once.
Mm-hmm.
So the reliability of functions is entirely dependent on the reliability of the trigger underneath it. So if you're using something like queues, you're going to have the same reliability of queues, which is pretty good. Like, you know that message is going to be processed, and if it does error out, it will end up in an error queue. Same with like service bus. So it's one of those scenarios where, like, if you have your service bus set up to do at most once delivery, then functions will run at most once on it, and that sort of thing. But if you have, say, an HTTP trigger, and HTTP is notoriously unreliable, then it's only going to be as reliable as what is triggering it. If that HTTP request is blocked by a proxy or something in between, or it just fails because the internet sucks, then it's going to lose that message. So I guess the takeaway from that is, if you want reliable communication, then use reliable transportation underneath.
One more question.
So I thought the whole auto-scaling feature was really cool. So could you theoretically stand up like a lightweight API behind all this to take advantage of that? Maybe set like a spending limit on how much you want to pay per month, depending on the traffic. Like, would that be a use case here?
Absolutely, that would be a fabulous use case for it. Because if your API isn't used, it's not going to really cost you anything at all. Depending on what storage and stuff you have behind the scenes. So it would be great for that. This is just another kind of example of creating a startup even cheaper on top of Azure. In theory, if nobody uses your startup, then your cost is zero.
And I posted a link in the chat. Simon, if you want to actually,
don't worry, they can't see it.
Yeah, Simon, if you can go to the chat and just paste that URL into.
Oh, yeah, there we go. So it started up. So let me run that again, because I still have this open somewhere. So now I should be able to click on the short link and it should take me to Bing. Yeah, it does. Yep. There's a window and a castle. Very pretty.
Nice.
Do you want to give it a share? I can put our
You
Yeah.
gonna
last
show us the
slide up.
function?
I'm not going to show you that. Share. All right. So the last slide is just some contact info for us. Like I said, we have Function Junction, which is a YouTube channel that we have, and we're also posting the episodes that we post in the YouTube channel onto channel 9. And then we have some contact info for both Simon and I. If you have any questions, if you have anything that you would like to see, anything like that, please send us an email or something. We'd love to either write a blog post or do a video or something.
Eric, I mean,
Yes.
blue on blue.
I know, you know,
They would love to talk to you, but nobody can see it.
you can read it.
Well, the funny thing is, we only see Simon's email address.
Yeah.
We can't see Eric's.
Uh-oh.
Slide.
Looks like I'm going to be getting all the questions. It's okay. I will forward them to Eric.
Yes. And another thing about the Azure Functions team at Microsoft themselves, they are amazing. They are super responsive to Stack Overflow questions, to their GitHub issues, to Twitter questions, anything like that. We've had a couple of questions here and there. They reach out to you, like they sent us a bunch of the swag, which if you guys didn't yet, there's should be a bunch of swag in the back. And if you definitely take something, maybe take a picture of it and tweet it out at Azure Functions and, let them know you had a good time, even if you didn't. But yeah, they're great. Reach out to them, reach out to us. We'd love to help you figure anything out.
Well, thanks, guys.
All right.
Anytime.
All right. Well, I guess that's it. No overtime questions, nothing? Can stand here awkwardly for another few seconds. Make it really weird? No? All right. Well, why don't you guys just stick around just for a few more minutes in case anybody wants to come up and
Okay.
talk one-on-one or one-on giant speaker and all that. But otherwise, pizza, swag, and just one more reminder, jobs. Actually, his name's Glenn, but he has jobs.
Yes.
So
Yes.
for headsprings.com and
Headspring.com and
getworkify.com. All right, guys. Thank you very much.
Thank you.
Yuji, I know you got some questions. I'm just messing with you, buddy.
Have you,
No.
You don't have to try and sound smart. It's okay, you cheater.
I don't know, like, is there anything in your guys' current projects where you think an Azure function may be?
That's where I was going, yeah. So
There's something every day on mine, man. There's something every day I'm like, because my current client is in AWS. And every day I wish we were in Azure. Because there are so many things, like there's like database update, database cleanup that we could, do so easily with Azure functions that could just run in the background. Like we have some scripts that some data got messed up and we were trying to run it. It was going to take like 30 seconds per script and lock some tables. So it's like, hey, we could write a couple Azure functions to update these tables, throttle them, have a timer, run on a chrono schedule and just, run it every 5 minutes. So we're not really blocking anything. We're only going to use it for those 200, rows that we needed to update. But like it would remove a lot of complexity because Lambda just doesn't in AWS just doesn't have the type of, .NET story, that Azure Functions does, obviously. And it's hard to develop because we have to develop it in Node because the C# tooling isn't quite there yet. And we can't do the same stuff that we could do with Azure Functions. So database cleanup is one. We have some triggers, some HTTP triggers that we want, to manually kick off a couple processes, which, normally we would have to just add a new endpoint to one of the APIs that we have running somewhere and wait for the next deployment to roll it out. But like if we were on Azure Functions, we could use Azure Functions. We'd just spin up a new function, hit the endpoint in a couple minutes, and it's ready to go. Like it's not, like we were saying, it runs without context, so it's not going to be, interfering with anything else.
I got you.
So I think there's uses just about in every project that could benefit from using something like Azure Functions.
There's also a whole like DevOps story or infrastructure story too for alerting and all sorts of stuff that you can use for.
Right.
Use for chat ops and
Simple little webhook.
make little Slack commands out of it, just to do stuff for you. I mean, it's not it's not just extending your architecture application. You
Right.
improve your everyday operation.
I actually have an example. I think we have a video and I wrote a blog post on it of like just creating something, a Slack integration with an Azure function that will go out and look at VSTS to see if there's any open pull requests and how long they've been open for. And if there are, then it'll post to the Slack channel and say, hey, you guys have some open PRs you should go check out. Something like that. Like I think something like that would be useful because like it's just a timer trigger. It runs every hour, so it's not, running constantly and bugging everybody. An hour is probably a good amount of time for it, but it would only run, you can set it to where it runs 9 to 5, Monday through Friday. And then it doesn't do anything on the weekends. It runs once an hour. It's super lightweight. It makes an API call to VSTS. And then post back to Slack. So it's super lightweight. So, and I think Azure Functions, Simon, I don't know if I think I read yesterday, it was still 1 million requests are free.
100,000 maybe?
Is it 100,000? I thought it was, it's some high number. So like something like that, and I think it's a month.
Yeah,
too.
Something like that. 100,000 requests a month is free. And then after that, you pay per megabyte second, or gigabyte second.
Right, which that still even isn't that expensive. If you go to the calculator and you do a couple billion requests, it's not that much.
Like the 10,000 or so requests we put through tonight, I don't expect that will cost me anything.
Right, exactly.
The whole payroll allocation we're doing over at ClearMeasure, it's all done through a VM right now. Like if we can look at how much it's costing us a month, like we can move that to Azure Functions. Think about how much money we save.
Yeah, exactly.
Yeah, absolutely. If that's still using a VM, it probably shouldn't be because I fixed that already.
Well, the first 400,000 gigabyte seconds of execution and 1 million executions are free.
There we go.
Gotcha.
Thank you very much.
Thank you.
I think I have an idea.
They also something that I thought was super cool is they just added the attributes for stream analytics, I think. So the Azure Stream Analytics stuff. So you can definitely build some powerful stuff using the bindings with Azure Functions there. You want to hook into that.
And this stuff slots in really nicely to logic applications too. I don't really do anything with logic apps, but if you wanted to. Yeah, oh, look, Eric's wearing a shirt about it.
Yeah, the shirt's over there. Go get them.
Yeah, it slots in really nicely for that.
Yeah, for sure.